Bismillahirrahmanirrahim. Continuing with exercise 10.1, we are going to do question number 4 part 2. In this question we are again going to use the concept of allied angles. The first part is cos of 90 plus theta. Here this can be written as 1 times 90 plus theta, or secant of negative theta, and then we have tangent 180 minus theta, secant of 360 minus theta, sine of 180 plus theta, cot of 90 minus theta. Now taking the left hand side, we can write this as 1 times 90 plus theta. Now we know that cos of negative theta is equal to cos of theta, so secant of negative theta will also be equal to, we know that cos of negative theta is always equal to cos of theta, so reciprocal of cos of negative theta will be equal to reciprocal of cos of theta. We know that this is secant of negative theta, so it means that secant of negative theta is always equal to secant theta. I am going to use this result over here, so it will be secant of negative theta will be secant of theta. Again, tangent 180 can be written as, let me erase this, 180 can be written as 2 times 90 minus theta over, we can write 180 as 2 times 90 and minus theta, and here again 360 can be written as 4 times 90 minus theta, sine of 180 can be written as twice of 90 plus theta, and cot of, here is 90 minus theta, which can be written as 1 times 90 minus theta. Okay, now using the concept of the allied angles, we have the odd multiple over here. Okay, so 1 times 91 is an odd number, so cos will change to sine of the acute angle which is used over here. Cos of 1 into 90 plus theta will be sine of theta, and to determine its angle we have to find the quadrant in which this angle will lie. 90 plus theta means this angle is going to be lie, angle is going to lie, 90 plus theta means 90 is over here, 1 times 90 plus theta means you are going to be in the second quadrant. Now we know that in second quadrant cos is always negative, so cos of this angle will be negative because this angle lies in the second quadrant, and all the angles which lie in the second quadrant have only sign positive. Okay, all the other trigonometric ratios are negative, so the cos of this angle will be negative, so we are going to put a negative sign over here. Okay, this is equal to secant theta. Tangent of, here we have 2 times 90 minus theta. As we have even multiple of 90, so tangent will remain tan, so this will be equal to tangent of the angle given. Now in order to determine its sign, we have to consider the quadrant in which this angle lies. Okay, twice of 90 minus theta means that this angle lies in the second quadrant, because twice of 90 is 1 times 90, 2 times 90. 2 times 90 is over here. If it, minus theta means something is subtracted from this angle, so it is this angle will be in the second quadrant. As it is in the second quadrant, therefore its tangent will be negative, so you are going to put a negative sign over here. Okay, let's move to the denominator now. Secant 4 times 90, as you have an even multiple of 90, so secant will remain secant. This secant of this whole angle will be equal to secant of theta. Now in order to determine its quadrant, 4 times 90 minus theta means the angle will lie in the fourth quadrant, because 4 times 90 is 1 times 90, 2 times 90, 3 times 90 and 4 times 90. Minus theta means you are subtracting some angle from it, therefore your angle will lie in the fourth quadrant. As it lies in the fourth quadrant, and in the fourth quadrant we know that cos is always positive, so secant is also positive, so it means that secant theta will be positive, because 4 times 90 minus theta is in the fourth quadrant, and in the fourth quadrant cos of any angle which lies in the fourth quadrant is always positive, therefore the reciprocal of cos, that is secant theta, this will also be positive, so you are going to put a positive sign or no sign with it. Okay, sine of twice of 90, again we have an even multiple of 90, so sine will remain sine. Okay, and twice of 90 plus theta means that you are in the third quadrant. Okay, twice of 90 plus theta means twice of 90, this is 1 times 90, 2 times 90, plus theta means you are going to cross this line and add something to it. So we will be in the third quadrant. Now in the third quadrant, sine will be negative because this angle lies in the third quadrant, and the sine of all the angles which lie in the third quadrant are always negative. So we are going to put a negative sine theta sine. Okay, cot 1 into 90, again we have odd multiple, so cot will change to tangent theta, and 90 minus theta means you are subtracting something from 90, some acute angle from 90. So this angle will be in the first quadrant, and we know that in the first quadrant cotangent is always positive. So we are going to write a positive sign, or we won't write the sign, because if there is no sign, that is understood that that's a positive one. So here what we obtained is we have three negative signs. Okay, we are going to cancel out negative sine theta with this one. Okay, secant theta can be cancelled out with this one, and tan theta can be cancelled out with tan theta. The only thing remaining is a negative sign. So the answer is going to be negative 1, which is equal to the right hand side, and this proves the expression. Okay, so this is how you use the concept of allied angles to find the or to reduce the expression or to simplify the expressions. Now let's move to the next question, question number 5. Now question number 5. We are given that alpha, beta and gamma are the angles of a triangle. Okay, these are the three angles of a triangle, and we have to prove that sine alpha plus beta is equal to sine gamma. So as these are the three angles of the triangle, and we know that the sum of three angles of a triangle is always equal to 180 degrees. Okay, alpha plus beta plus gamma will be equal to 180. Now we want sine alpha plus beta, so I'm going to shift gamma to the right hand side. This will be 180 minus gamma. Alpha plus beta will be 180 minus gamma. Now in order to find sine, we are going to take the sine of both the sides. Sine alpha plus beta is equal to sine of 180 minus gamma. As these two angles are congruent, so their sine will obviously be equal. Now we have to prove that this thing is equal to sine gamma. Okay, we got the left hand side. Now you know that 180 can be written as 2 times 90 minus gamma. Now 2 times 90 minus gamma, as it is an even multiple of 90, so the sine of this whole angle will be equal to sine of gamma. Sine will remain sine. Now 2 times 90 minus gamma is in the second quadrant. Okay, this angle will lie in the second quadrant because twice of 90 is over here. Minus gamma means you are going to subtract some acute angle from it, so this angle will be twice of 90. It is in the second quadrant, so sine will remain, sine of this angle will be positive. So we are going to get sine alpha plus beta is equal to sine gamma, and this is what we needed to prove. Okay, similarly the second part we have proved it by using the concept of the allied angles. Now the second part is that we have to prove that cos of alpha plus beta by 2 equals to sine of gamma by 2. Okay, this is what we need to prove. Now as alpha and beta and gamma are the angles of a triangle, therefore their sum is going to be equal to 180. Now dividing both sides by 2, alpha plus beta, or let us first shift gamma to the right hand side. We can do it in either way. Okay, it's up to you. You can first divide and then shift, or first shift it to the right hand side and then divide. Now dividing both sides by 2, because we know alpha, we want alpha plus beta by 2, and dividing this by, this will be equal to 180 by 2. minus gamma by 2. Okay, so this is going to be alpha plus beta by 2 equals to 180 by 2 is equal to 90, and 90 minus gamma by 2. Now taking the cos of both the sides, what we are going to have, as these two angles are congruent, so their cosine will also be congruent. Okay, the cos of this angle will be equal to cos of 90 minus gamma by 2. Now over here we have an odd multiple of 90. Okay, 90 can be written as 1 times 90. So it means the trigonometric ratio will change to its co-ratio. Cos of 1 times 90 minus gamma will be equal to sine of gamma by 2. And its sign, in order to determine its sign, we are going to find the quadrant in which it lies. 1 times 90 minus gamma by 2 means this is an angle which is obtained by subtracting something from 90. It means it is going to be in the first quadrant, and we know in the first quadrant all the trigonometric ratios are positive, so cos of this angle will also be positive, so we are going to put a positive sign. Now as you may see, we have obtained this expression, so it means that cos of alpha plus beta by 2 is equal to sine of gamma by 2. Okay, this is how we can calculate this expression. Now let's do the remaining parts. Okay, the next part is we have to prove cos of alpha plus beta is equal to cos of gamma of the same question. Okay, so again we are going to start with the same expression, that as alpha plus beta plus gamma is equal to 180 degrees, so alpha plus beta will be 180 minus gamma, and taking cos of both the sides, cos of alpha plus beta will be equal to cos of 180 minus gamma. As it is an even multiple of 90, so cos will remain cos gamma, and 180 minus 90 means it is in the second quadrant. 180 minus gamma means the angle is in the second quadrant, so this is equal to be negative cos of gamma. Now there should have been a negative sign over here. Okay, so do the correction in your book. There should have been a negative sign because cos of 180 minus gamma lies in the second quadrant, and cos of the angle which is in the second quadrant is always negative. So there should have been a negative sign over here. Okay, so put the negative sign, and this will prove the result. Okay. So do the correction in the question. The question in some books is with positive sign, which is wrong. You have to put a negative sign with it to get the right result. Now let's move to the next part. The next part is you have to prove tangent of alpha plus beta plus tan of gamma is equal to 0. Okay. Again we are going to start with the same discussion. All these four parts are of the same method. Okay, alpha plus beta plus gamma is equal to 180 degrees. So alpha plus beta will be equal to 180 minus gamma, and taking tangent of both the side, tangent of alpha plus beta will be equal to tangent of 180 minus gamma. Okay, this 180 can be written as 2 twice of 90 minus gamma, and as it is an even multiple of 90, again using the concept of allied angles, tangent of this angle will be equal to tangent of gamma. Now this angle lies in the second quadrant. Okay, lies in the second quadrant because it is twice of 90 minus some gamma. Okay, twice of 90 minus something, it means some acute angle will be subtracted. Okay, the unknown angles are always taken as acute angles. Okay, so 2 into 90 minus gamma will be equal to, this will be in the second quadrant, and we know that in the second quadrant tangent is always negative, so we are going to put a negative sign over here. Now shifting this to the right hand side, we will get the required result. This is equal to negative tangent gamma, and shifting it to the left hand side, from the right hand side we are going to get this result. Okay, and this was what they required us to prove, so we have proved the result. Okay, and this completes the exercise 10.1.